some ideas. So what we're going to talk about on this is two types of functions. First type of function what we're going to talk about is a polynomial function. So we'll talk about that. So I want to kind of go over what a polynomial function is. We've already seen these, so just kind of a couple of examples on this. So a polynomial just means you have sums and differences. You just add and subtract whole number powers of x. Whole numbers are numbers like 0, 1, 2, 3, 4. Numbers you count with, but starting with 0. All right, so let me show you 3 examples of polynomials. You just want to get in your mind what they look like. So here's how you make a polynomial. We'll just start off with f of x. I'm just going to put some x's in there. It doesn't matter how many you have. And then what you got to have is just put some exponents. Those exponents, as long as they're whole numbers, then you're okay. Like x the third, x the second, x the eighth. And then you just got to add and subtract. They can be all addition, all subtraction, any combination you want. And then you can put any number in front of these that you want to. Fractions, decimals, whatever. That's a polynomial right there. So you have x to a power. You might have a series of several of those things. As long as the exponents have whole numbers, then it's a polynomial. Okay? All right, let's get 3 examples on this. Okay, so, or at least 2. So on this we have, just write down 2 x's this time. Put a whole number. I'll say that's 10. I'll say that's 5. Okay? And then either add or subtract. Okay, that's a polynomial right there. Okay, that's it. One other possibility would be something like this. You could just have a number. Okay, that's also a polynomial like that. It's okay. You don't have to have an x in there. You could just have a number. You could even have a number at the end of those things, something like that. So just for yourself, try to think of a polynomial is x's to whole number powers, added or subtracted. That's what they look like. That's the structure. Okay? So there's 4 types of graphs that we're going to look at. And when you graph a polynomial function, they will always kind of look something like this. They kind of have curves to them, but the thing is, they will either both turn up like this at the endpoints, or they'll both turn down. It's kind of like the parabola. It either opens up or it opens down, but they may kind of wiggle a little bit in between. So that's one case. The other thing is maybe one side goes up and the other side goes down, or backwards. Okay, there's 4 possibilities like that. So a polynomial's graph is always going to be smooth, no breaks, but it might look something like that. Okay, that's a polynomial graph. Or both sides may turn up like that. Those are the 4 possibilities that you have. So what I'm going to show you is the thing we call the leading coefficient test, which shows you how to determine how a graph looks. When I give you a polynomial function, you'll know very quickly what the graph looks like, basically, without having to rely on your calculator. Okay? All right, so this is kind of, I think of these as like dance moves or something. So here's kind of the idea. If the highest power is odd, then the graph's going to look like this. Either the dancer goes like this or it goes like this. So it's one of the two. Anytime the highest power is odd, the graph does that. That's what it looks like. So I'm going to give you an example to write down on this first one. Let's say that you have f of x, and I'm going to make the highest power some odd number, like 5. What comes past that doesn't make any difference. You can have anything you want past that. As long as the number in front is positive and that highest power is odd, then the graph is going to be guaranteed to do this. When x goes to infinity, the graph goes up forever. When x goes to negative infinity, the graph goes down like that. We call that the endpoint behavior. So as long as the highest power is odd and the number in front of x on that highest power is positive, that's what your graph looks like. That's what this dancer is showing you, is the arms are showing you how the polynomial goes. Okay, it's like that. Okay? What comes past that, the x to the fifth, doesn't matter. Okay, here's an example of the second one. Say you have g of x. Okay, your highest power is odd. As long as that's odd, and if you put a negative number in front, then everything just reflects. Okay, so the way this one would look is more like this. Okay, if you had this, then it would go like this, and it would go like this. We're not concerned about what goes in the middle, so it's like that. Okay, so what that's representing is this dancer, a disco man there. Looks like that. Okay? So it goes like this. Odd power, positive coefficient goes like this. Negative goes like this. Okay? So that's how odd degree polynomials look, is like that. I'm not going to talk too much about why that is yet. Then we'll go to the even ones. The even, just think of what you learned about a parabola. Okay, so if the highest power is even, the leading coefficient is the number in front of the highest power. If that's positive, then it's going to look like this. Okay, so I'll give you an example. So let's say we have f of x equals x to the fourth. As long as that's an even exponent, the highest power is even, and if the number in front's positive, think of that like a parabola. If the number in front of x squared is positive, the parabola went up, right? Okay, so what would happen on this is this graph would look kind of like that. Okay, that's what that dancer is trying to show, is that's an even degree polynomial. That's what the graph's going to look like. Okay, there's 4 cases, so that's 3. Okay, the next one goes like this. If you have an even and the leading coefficient's negative, it'll look like this. So let's write this example down. All you got to do is use an even exponent for your highest power, and then put a negative there, and then it'll just make everything turn down because it's a reflection. So the graph of this function right here would basically look like that. Okay? So there's 4 cases that we're going to try to get straightened out, and it's pretty straightforward. If the highest power is odd, it's either this or it's this. Okay? If it's even, the highest power is even, what is it? It's either this or it's this, depending on whether that number in front of the highest power is positive or negative. Okay? So these are just kind of some rules that you're learning. Okay, so let's try to begin to put this all together. Okay, if you go to this example 1, what is the highest power of x you see on this first example? 3. Okay, that's an odd number. That's what matters, is that it's an odd number. Okay, the leading coefficient is the number in front of that, which is -1. All those other numbers have no bearing whatsoever. All you look at is the highest power, and that will tell you. Okay, so this resembles the function y equals -x to the third. So if you graphed y equals -x to the third, and then the one I gave you, they would look very similar. Okay, so this one goes like this. If it's an odd polynomial, what does it do? It's either this or it's this. You just got to distinguish between the two. Since you have a negative leading coefficient, the graph goes like this, and it goes like that. We don't care what happens in the middle. It may kind of curve around and stuff like that, but that's not what matters. Okay, we're just looking at what we call the endpoint behavior. Okay, so that's how that goes. All right, now this is what this jargon right here means. This says x goes to infinity. That means as x gets big, what happens to the y value? As x gets big, where does the graph go?
Down.
Down, -infinity. This part right here says as x goes this way, as x gets small, what happens to y? It gets big, okay? So this is saying x gets big, y goes to -infinity is what would go there. If x gets small, y goes to positive infinity. That is the terminology with that arrow. It means that then. Okay, so this one would mean -infinity, and then this one would be positive infinity. See, that one's going to plus infinity, that one's going to -infinity, like that. Okay? Okay, the highest power on the next one is 4, so that's what matters. This is an even degree, so that's going to tell you that the graph is either going to go like this or it's going to go like that. We just got to distinguish between the two. That's all we care about. The leading coefficient is the number in front of that x to the fourth, so that's a +1. Since it's positive, which one is it? Opening up or opening down? Opening up. Okay, that's how that goes then. Okay, so that means the graph of this would look like this, kind of like that. So it's going to infinity in both directions like that. Okay, and this graph is almost the same as y equals x to the fourth. If you graphed x to the fourth and graphed x to the fourth minus 4, they'd look almost the same. Okay, so that would go kind of like that. All right, and again, what this step right here is saying is this. If x gets big, x goes that way, where does y go? Goes to infinity. This means x gets small, where does y go? Infinity. So they're both going to infinity when you write that down. Okay, that's what that means. Okay, real simple if you get this all distinguished in your mind. Yeah.
You need to put the positive symbol?
What's that? No, you don't have to. If you put infinity, that's good enough. But you do have to put the negative one, of course. Okay? Okay, let's go to this next page. Then I'll kind of give you a summary of what we're doing here. So this one right here, the highest power in this problem is x to the fifth. So that's an odd. So that's going to mean on this problem, the graph's either going to kind of look basically like this, or it will go backwards. Okay, what tells you the difference is the leading coefficient. What's the leading coefficient in this problem?
1.
1. So it's positive 1. That's what matters, so it means it's going to be this first one. So your graph is going to go like this, and it's going to go like that. That's it, okay? What you do is you don't look at the rest of the things. You just look at y equals x to the fifth. And if you put that in your calculator, you get a graph. It kind of looks like that roughly, okay? All right, so what is this one? X goes to infinity. If x goes to the right, where's y going? Positive infinity. So the first one's positive infinity. Okay, the next one is x goes to the left. Where's y going? If you go that way, where does y go?
Negative.
Negative infinity. Okay, so that's what that means then. Okay. Okay, and here's one last one. So this one, the highest power is 2. Okay, what's the leading coefficient in this problem? Negative 1, right? Okay, that's always the number in front of the highest power. Okay, so since it's an even, what are the two possibilities for an even polynomial? This or that. Which one is it?
Down.
This one, okay, because of that negative. So that means this one's going to go like this. That's what the graph looks like. Again, we're just kind of looking at how the endpoints of this work. We don't care about what goes on in the middle. Okay, so this is almost the same as the graph of y equals negative x squared, which you know that's a parabola that's reflected anyway. Okay, so that's how that goes. So this would be as x goes to infinity, where does y go? Y goes to negative infinity. If x goes to negative infinity, y goes down to negative infinity like that. Okay, so there's 4 possibilities. If it's odd, what does it look like? This or this? If it's even, what does it look like? This or this? Okay, that's it. All right, it all depends on what that highest power is and what that leading coefficient is. So this is a summary. I'm not going to go over this. This is just for you to look at if you need to. This would give you the 4 possibilities that you have. Even degree are those two. Odd degrees are those two right there. Okay, you just want to know the difference between the two. Okay? Okay, let's do these just kind of together on this thing, because you're just now kind of learning this. So let's see on this one. So problem number 1, I give you a graph. Okay, would the highest power be an odd number or an even power? It'd be an odd. How do you know? Because it does this. Okay? Is the leading coefficient positive or negative? It's positive if it goes this way. It's negative if it goes this way. So that's a negative one right there. Okay? So that's what you're kind of learning there. Okay? Okay, problem 2. Is that odd or even? Even. Is the number in front of the highest power negative or positive?
Negative.
Negative. There you go. Okay, like that. Okay? How about the next one? Odd or even? Odd. Leading coefficient?
Positive.
Positive. Okay. Next one?
Even.
Even. Leading coefficient? Positive. Okay, so just sorting out those 4 cases. Okay, that's the way those graphs are always going to look. Okay, so that's called the leading coefficient test. Is there any question about that? You can just get the odd going this way and the even going this way, you got it made. You can figure out which is which. Okay. Okay, so we're going to do a little bit with x-intercepts. So we've been talking a lot about x-intercepts. So an x-intercept's a point on the x-axis. If a point is an x-intercept, y is 0. So x-intercepts would just, I'll give you a couple of examples. You could have 3, 0. We've already done this. You could have negative 2, 0. You could have 10, 0. The thing is, on an x-intercept, the y value is always 0. So we're going to go back to kind of talking about intercepts in another part of this section too. Okay, a y-intercept is a point that's on the y-axis. That's just when x is 0. Okay, so examples of y-intercepts would be something like 0, 5. That's on the y-axis at 5 units. You could have 0, negative 2. 0, 1. Okay, the point on a y-intercept is x is 0. Okay, we've already learned that. It's just the opposite variable goes to 0 on an intercept. So we've talked about that already. Okay, so on this next page, we're going to do some intercepts of different types of polynomial functions. Some of this stuff's going to have to do with factoring. A lot of it is, in fact, but not everything. Okay, let me ask you a question on this example too. What kind of function is that? What have we learned so far? Constant, linear, polynomial. Which is it? Linear. How do you know? Y equals mx plus b, right? Okay, that's a linear function. The degree is the highest power of x, which is 1. Okay, so we're going to go ahead and just find the intercepts on this then. So the way you find an x-intercept is you just set the function equal to 0. You just take f of x, set it to 0. So you're just going to plug a 0 in for f of x to get 0 is 3x minus 9. Then you solve that equation. That's going to have one answer to it. So this is a real easy equation to solve. You add 9 to both sides, so you'd have 9 equals 3x. Divide by 3, so it looks like you'd have x equals 3. Okay, so you would write that x-intercept as 3, 0. Okay, y is 0. We found the x value that does that. Okay, y-intercept. What do you do to find a y-intercept? You set all of the x's equal to 0. Okay, so you just go to your function and you just do f of 0. So where you see an x, you just plug in a 0. So that's going to be 3 times 0 minus 9. So that's negative 9. Okay, so that means the y-intercept on that would be negative 9. Okay, now I want to see if you guys spot something on this. Okay, I hope you do. Okay, this is a line, right? What is 3? 3 is the slope. What is that? Y-intercept. That's what we got anyway, right? Okay, that's what you should get. That's just because that's a line. Okay. Okay, now all the rest of these problems are done exactly the same way. If you're going to find an x-intercept, let the function be 0 and solve. If it's a y-intercept, let x be 0 and do the arithmetic. So the rest of these problems are going to have to do with factoring. So hopefully you're starting to get your factoring down good. So when you do the x-intercept, you're just going to replace that g of x with 0. And then that's the equation we got to solve. Okay? So you can factor this. If you want to factor this, this one is the one that is a difference of 2 squares. So it goes x and x, and then 5 and 5. How do the signs go? Plus minus. Okay, that's a perfect square. 25 is a perfect square. Now you can do the x-intercept in your head if you want to. You would just do x plus 5 is 0, and then you do x minus 5 is 0. So what are the two answers to those two equations? Negative 5 and 5, right? Okay. And you don't have to show the work on that because it's easy enough to do in your head. So that would be one of your x-intercepts. The other one you would add 5 to both sides, so you get x equals 5. Okay. So you would say your intercepts, the first intercept we just say negative 5, 0. The second one we say 5, 0 like that. So those are your two x-intercepts. Okay. What is the degree of this? 2. The highest power is 2. So therefore, what does the graph do? It does this. It's a parabola, right? Okay, so we know that's an even degree, so it does that. Okay? Okay, y-intercept, you let x be 0. Okay, so you just do g of 0. And usually you can do y-intercepts in your head. You just do 0 squared minus 25. So what is that? 25. Okay, so that would give you the point 0, negative 25 like that. Okay, so we had two x-intercepts, then we had one y-intercept like that. Okay, that's a parabola that's opening upward. It's a polynomial. A quadratic function is a polynomial. Okay, the next two we'll do exactly the same way. Okay. So with this one, let's see, the degree on this one is 2. The graph is going to do something like that. Okay, we know that. The x-intercept, you're just going to set the function equal to 0. So we'll have 0 equals x squared minus 6x minus 27. Okay, I think that will factor. It should factor. I'm trying to make these up so they factor. Okay, so we go like this. So we'd have x and x. What should I use for 27 on this problem?
9 and 3.
What's that?
9 and 3.
9 and 3, right? Okay, 9 times 3 is 27. So we do the factoring there. That's 9 and 3. How do you make 9 and 3 add up to negative 6x? Okay, the 9 has to be minus, and then 3's got to be plus. Okay, so that means you'd have a minus there, you'd have a plus there. Okay, what are the two answers of that equation in your head? 9, what else? Negative 3, right? Okay, so you can do that last step in your head. X minus 9 is 0, x plus 3 is 0. So your intercepts are going to be 9, 0, that's your first x-intercept. The other one would be negative 3, 0. Okay, we let y be 0 and found the x that's associated with that. Okay, now you can get to a point where all these you can do in your head for the y-intercept. Does anybody know what the y-intercept is in their head? Yeah, okay, what you do is let x go to 0. There's your y-intercept right there. It's negative 27. Okay, you can do that in your head on all of these polynomials. Okay, so what you do is just f of 0. So that would be 0 squared minus 6 times 0 minus 27. So that means that works out to be negative 27. So those are your intercepts on that problem. Okay. Any questions? We've done intercepts a bunch in this class for lots of different types of functions. So it kind of gets to a point where we'll be a little bit repetitive. Okay, the next one, the degree is 2. And then this is the kind of factoring that I see students struggle a lot with. You're going to let the function go to 0. So we have 10x to the second plus 9x minus 15. I usually teach how to do this by trial and error. Okay, so the first term, we have two choices. It could either be 10x times 1x to get the 10x squared, or it could be 5x times 2x. So it could be either one. We have to figure out which it is. The last term, you're looking for numbers multiplying to give 15. So that's either 1 and 15 or it's 3 and 5. Now you can't do this problem in your head. You just can't. You have to write something on your paper. And you got to just kind of pick stuff. I usually tell students to kind of pick what's close together. So 5 and 2 are closer together than 10 and 1 are. Same thing with 3 and 5. So what I'm going to do is just put a 5x there, a 2x there, and then 3 and 5 and see if it's right or not. And then if it isn't, we'll adjust and try again. Okay, well, the key thing is the middle term has to come together to make 19. Okay, so if you did this, this would be 6x there. That outer would be 25x. We're trying to make 6 and 25 add up to 19. Is that possible? Yep. How do you make it happen? Yeah, 25 is positive and 6 is negative, right? Okay, so you can't do that in your head. You got to write that on your paper to see how those things come together. So that means this negative goes there, so you get the negative 6. And then the plus goes with the 5, so the outers come together to give you plus 25. Okay, so what you would do from there then is just set those two factors equal to 0 and solve each equation. So you're going to have intercepts on this that are fractions. So we'd have this and this. Just solve those two equations. Okay, with practice, you can do this in your head too. I'm going to add 3 to both sides. That's going to give 5x equals 3. Then I can divide both sides by 5. So one of my x-intercepts is 3/5. Okay, so I'll just record that as 3/5, 0. That's my first one. Second one, same idea, just subtract 5. You get 2x equals negative 5. Divide by 2, you get x equals negative 5 over 2. Okay, so the second x-intercept is negative 5 over 2, 0. Like that. Okay, so it's factoring. So on the last 3 examples, I did factoring. Now, I'm kind of hoping you can do this one in your head. So what's the y-intercept in your head? Negative 15, right? Okay. So you don't have to put anything on your paper on that. You just got to know how that goes. Again, you're doing g of 0. So that's 10 times 0 squared plus 19 times 0 minus 15, which works out to be negative 15. Okay, so in this problem, you've got these 2 x-intercepts and that one y-intercept like that. Okay? And when you're dealing with quadratic equations like we're doing here, most of the time you'll have to factor to find the x-intercepts. Okay, yes?
You can't use the quadratic formula?
You can. You can always do that too. And another thing is if you have trouble factoring, you may not see how the factoring goes maybe on this one because it's harder. You can plug it in the formula and you'll get those 2 things. The problem is your calculator would give that like in a decimal. That would give like 0.6. That would give like negative 2.5. But you can always use that quadratic formula to help you with factoring if you want to. Okay? Okay, any questions?
Would you accept leaving that, like, would you put the formula in for, like, the, what is it?
Yeah, I would take a decimal on these. I mean, my preference for you guys is to learn how to factor real good, so you don't have to do that. But if you had to do the quadratic formula and say you got 0.6 and negative 2.5, I'm not going to count that against you because you're right. Okay? One of the benefits of not doing the quadratic formula, sometimes your decimals repeat. So if you ended up with 0.666 like that, you have to round so you're not exact. Factoring is always going to give you an exact answer, say. So that's the idea. Okay, so let's see. Let's go to this next thing here. I want to we'll get through the polynomials and I'll start you a little bit on the rational stuff here. Okay, so this one right here, you wouldn't want to multiply all this out. This is already in a factored form, so it's nice. Okay, the way you find the degree on this is you just add those 2 numbers together. So you do 2 plus 3 and you get 5. Now here's the thing. I'm just going to explain this. I'm not going to do this, obviously. But if you wrote that out twice and FOILed it, the highest power would be x to the second. If you wrote that out 3 times and multiplied it out, the highest power would be x to the third. So all you're really looking at is x to the second, x to the third. So x to the second times x to the third is x to the fifth. So that gives you the degree. And that would tell you on this graph that your graph would probably look kind of like that, like we learned. Okay, roughly like that. Now when you do your x-intercept, this one you're going to do in your head. Okay, what you do is just set f of x equals 0 like we've been doing. So you'd have 0 equals 2x minus 7 to the second times x minus 8 to the third. So what you do is like we've been doing on all these problems, once you get it factored, then all you really do is just set the factors equal to 0. And you don't worry about the second and third power because they don't have any bearing on this. So what you would solve is 2x minus 7 equals 0. The second power makes no difference whatsoever. And then you would do x minus 8 equals 0. That's how you would get your 2 x-intercepts. Okay? So this one's pretty easy. You would add 7 to both sides. You can even move that to get 2x equals 7. Then if you divide by 2, your first x-intercept would be 7 halves. So we would have 7 halves 0 would be your first x-intercept. Okay? What's the second x-intercept? 8, right? You can do that in your head. So you can add 8 to both sides or just process that in your head. So you would end up getting x equals 8. Okay, so we got that. See, if it's already factored, it makes it easy. Okay, the problems I did before, we had to do the factoring ourselves, but these 2 examples are already factored. So it makes it a lot easier to go through and find those intercepts. Okay, it's a little harder to do the y-intercept in your head on this one, but what you would do is the same thing. You just let x be 0, so you do f of 0. So what you want to do is take the problem I gave you, and everywhere you see an x, just replace it with 0, and work out the details. Now this one you're probably going to have to maybe use your calculator on a little bit to get this going now. So what I'll have here, if you look at that part right there that I highlighted, that's going to be -7 to the second. Then this part right here, the second part is going to be -8 to the third. And then this is going to be a pretty big number, so we're going to have to probably do this on the calculator then. Right? All right, so I'll show you kind of how you can do it. You can do this in one step too if you want to. So what I know is -7 to the second is 49. And if I do like parentheses -8 to the third power, that'll give me like -512. So what I got to do is just take 49 times -512. That'll give me that Y-intercept on that. Okay, so I'm going to take that number times 49. And that's going to be where this thing crosses the axis, way down at -25,088. Okay, so your Y-intercept would be 0, -25,088 like that. Now that one's just got to have a calculator to probably do that and get that one, you know, accurate because the numbers are pretty big. That's the same thing. You can't do the Y-intercept in your head on these problems because it's harder because you got those exponents. Okay? Okay, let's look at this next one here. Can you guys tell me what the degree is? You got to be careful on this. I'm just curious if anybody can do that. No, that's what I was thinking that you might do. That's not right. Okay, here's what you got to do. Let me zoom on this just a little bit. Okay, what matters is this and this, this and this. So what happens on this is if you FOILed this out, if you took the first one and FOILed it, you would eventually somewhere do 4x squared times 4x squared. Okay, so if you're going to find the degree, what really matters is not even the 4, it's the x to the second to the second. And then inside here, what matters is x to the third to the fourth. Okay, that'll give you the biggest power. You don't have to multiply that stuff out, you just do this. So x to the second is x to the fourth. What is x to the third to the fourth? Is it 7th or 12th? 12th. You multiply. Can you tell me what the degree is now? What?
16.
16. Good. Okay, so it's 16. That is a 16th degree polynomial. And see, what matters is you got to look at this. That's what matters is the second power, x to the second, and x to the third to the fourth. Okay, that's what you do. Okay. To get that. Now, when you do your intercepts, the intercepts are going to be pretty easy on this. So what we do is just take what's in the first parenthesis, which is 4x to the second minus 9, and we set that equal 0. We solve that equation. Then we take the second one, which is x to the third plus 1 equals 0. So if you can solve those two equations, then you'll get where what your x-intercepts are. Okay? All right, does the first one factor, 4x squared minus 9? Does that factor? Yeah, how does it factor? 2x, then what? 3, signs? Plus minus. That's the difference of two squares, okay? All right, so this goes like this. We have 2x plus 3, and we have 2x minus 3 like that, okay? So that's how you'd solve that. That's one way to solve that. And then you can just solve these two equations. So I'm going to just do this at the side. 2x plus 3 equals 0. You would solve that. You'd also do 2x minus 3 equals 0 and solve that then. Okay? All right, so this one we could subtract 3. 2x equals -3. Then we could divide by 2. So you would end up getting -3/2 would be one of your x-intercepts. So you would write that as -3/2, comma 0. That would be your first x-intercept. Okay. Second one would work the same way. You would add 3 to both sides. So that's 2x equals 3. Divide both sides by 2. So the other answer, other intercept is 3/2 and 0. Okay, so that's just setting the factor that's already factored equal to 0 to solve that. Okay, the next one, let's see. This one does factor, but I'm not going to show you how to do that. That's kind of something you don't need to know how to do. what you could do on this one is subtract 1 from both sides. Okay, then what you would get is you would get x to the third is equal to -1. Okay, do you know what you do to both sides to change the x to the third into x? Cube root, good. Okay, some of you know that. Okay, so you'd now do a third root of both sides. Do you know what the third root of -1 is? What number would you multiply out 3 times that would give you -1? -1. -1 times -1 times -1 is -1. So you would also get another x-intercept of x equals -1. Okay, so what we'd have is -1, 0, like that. So those are your 3 intercepts. Okay, all right, y-intercepts, you're going to replace all the x's with 0, just do g of 0. So go to your problem I gave you and just replace all the x's with 0 and work out the details. You may have to use a calculator on this. We'll kind of find out. Okay, so I just plug in like that. Okay, this is going to be, that goes to 0, so that's -9 to the second. The second one, that goes to 0, so that's 1 to the fourth. -9 times -9 is 81, and 1 times itself 4 times is 1, so that would give 81. So your y-intercept would be 0.81 like that. Okay, so that's it. So that's how you would do your intercepts on these. You'd have to do the factoring. There's all kinds of algebra going on in there. So most of it is factoring and solving equations, and the y-intercept's always doing arithmetic. Okay? All right, that's a good stopping point. We'll finish this up next time. You guys also need to bring 4.1 to class next time. Okay? When we finish this, that was where our test ends. But we're going to do a little bit of 4.1 before we do a review next time, too. Okay? So I want to bring that, and then we'll... What's that?
You going to the office right now?
I am. So come by. I'll be there for an hour.
When are we doing the review?
What's that?
When are we doing the review?
We're going to do that at the end of class on Wednesday.
What are we going to turn in, like, our notebook?
You turn it in here Monday.
Oh, this Monday?
Next Monday. The day of the test. You always turn your notebooks in on the day of the test.